Good morning, dear students. Welcome back to physics class. Today, I would like to teach you two topics which are A. Verification of law of conservation of energy, and B. Rate of doing work or power. In last class, you had studied the law of conservation of energy. What is law of conservation of energy? Law of conservation of energy states that energy can neither be created nor be destroyed. It can convert from one form to another form. Total energy before and after the energy transformation remains same. Or total amount of energy of a system remains unchanged. That is, loss of energy will be equal to gain of energy. Now, let us discuss on how can verify the law of conservation of energy. Let us consider an object which is positioned at a point A at a height h from the ground level. It has only potential energy due to its height from the ground level. Its kinetic energy will be equal to 0 because it has 0 velocity. Then, what should be the mechanical energy of the body at this point? It is the sum of both potential and kinetic energy. It is equal to mgh plus 0 is equal to mgh, which is the expression 1. Allow the object to fall freely and you see the position B to where it has reached in certain time. See the figure given below. Let x be the distance travelled by the body when it reaches to the point B with a velocity v0. Let h0 be the height of the body when it is positioned at this point. So, it has potential energy as well as kinetic energy. The potential energy Pe is equal to mgh0 and its kinetic energy Ke is equal to 1 by 2 mv0 square. As shown in given figure, h0 is equal to h minus x. So, its potential energy Pe, which is equal to mgh minus x. We know that third equation of motion v square minus u square is equal to 2as. In this case, the equation becomes as v0 square minus 0 square is equal to 2gx. Here, final velocity is v0, initial velocity is 0, a is changed into g, where g be the acceleration due to gravity and distance travelled by the body in this time is x. Then, the third equation of motion is changed into v0 square is equal to 2gx. So, what should be the change of the expression for kinetic energy at this point? The expression for kinetic energy Ke is changed as 1 by 2 m into 2gx is equal to mgx. In the place of v0 square, we have used 2gx. Then, what is the mechanical energy at the point B? It is equal to Pe plus Ke is equal to mgh0 plus mgx. mg is common, then it is written as mg into x plus h0. Since x plus h0 is equal to h, then mechanical energy at the point B is equal to mgh, which is the expression 2, to where it has reached within a little time. As the object is touching on the ground level, it has zero potential energy since h is equal to 0. But it has maximum kinetic energy because of maximum value of velocity. So, its mechanical energy at the point C is equal to Pe plus Ke, which is equal to 0 plus 1 by 2 mv square is equal to 1 by 2 mv square, where v be the velocity at the point C. We have third equation of motion, v square minus u square is equal to 2as. In this case, the equation is changed as v square minus 0 square is equal to 2gh. Then v square is equal to 2gh, where h be the distance travelled by the object. So, the mechanical energy at the point C is equal to 1 by 2 mv square is equal to 1 by 2 m into 2gh is equal to mgh, which is the expression 3. From the expressions 1, 2 and 3, it is seen that mechanical energy, which is sum of both potential and kinetic energy, is constant at any point. So, it is said to be conserved. This is the verification of law of conservation of energy. The topic I am going to discuss is rate of doing work or power. Can you answer this question? Can it be the same rate of work done if two or more objects do the same work? Do machines consume or transfer energy at the same rate? If one object do the same work in lesser time than other, it can say that the object has done more work in unit time. You can understand that objects that transfer energy do the work at different rates. Let us do the activity to understand this concept. Consider two children named as A and B. Let us say they weigh the same. Suppose both are climbing up a rope separately. Both reach a height of 80 meters. Suppose the child A takes 15 seconds while the child B takes 20 seconds to accomplish the same work. What is the work done by each? Can you say the work done by each of them same? Definitely. The work done by each of them is the same. In spite of they are doing the same work, they are taking different times. That is, A has taken lesser time than B to do the same task. So, A has done more work than B in unit time. Therefore, rate of doing work of A is greater than rate of doing work of B. Since rate of doing work is equal to total work done divided by total time taken. Now, I point out two different situations. First one is a stronger person may do certain work in relatively less time. And second one is a more powerful vehicle would complete a journey in a shorter time than a less powerful one. Here, I have mentioned the word powerful. What is power? Power means the speed of doing work. That is, how fast or slow work is done. It is defined as the rate of doing work or the rate of transfer of energy. If a body or an agent does a work W in time t, then power is given by power P is equal to work done by time is equal to W by T. It means that the agent may be doing work at different rates at different instant of time. So, the concept of average power is introduced. We can find average power by dividing the total energy consumed by the total time taken. So, average power is equal to total work done divided by total time taken. What is SI unit of power? SI unit of power is watt. It is denoted by W. 1 watt is equal to 1 joule per second. Larger rates of energy transfer can be expressed in kilowatts. 1 kilowatt is equal to 1000 watts. It is 1000 joule per second since 1 watt is equal to 1 joule per second. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.